All right, guys, we're going to do an example of a probability problem that can be solved using a binomial distribution. Here's our problem. A beauty pageant selects the top 3 contestants for their scholarship program. From a pool of 50 contestants, 18 of which are minorities, there's a probability of 0.17 that a minority will reach the top 10. What's the probability out of the top 10 that 3 of them are minorities? We're going to assume that all are equally likely. So on an exam, you're not going to be told it's a binomial distribution problem. So let's talk about the 3 requirements that must be satisfied in order for it to be binomial. There needs to be a fixed number of trials, and there are. We're looking at the top 10. There needs to be 2 outcomes, and in this case, we're looking for a minority or not, so that works. And the third is that each person chosen has to have an equally likely chance or be independent of the others. And here it tells us, assume that all are equally likely. So we are going to solve this problem using a binomial distribution. Here is our formula. If you're going to do it by hand, I will also show you how to do it using your calculator. And I will have a video separate from all of the others that will show you how to do a lot of these things using Microsoft Excel as well. So here's the formula. Looks a little daunting, but it's not. We've got n, which is the number of trials. And in our case, we're looking for the top 10. X, the number of successes. And here we have to think about, what is a success? Well, how this problem is set up, it would be a success if a minority was chosen. And we want to see 3 of them chosen out of the top 10. And the probability of success, they gave us 0.17. So we have all the things that we need to be able to plug into this equation. We have 10 positions. We're choosing 3. The probability of success is 0.17 raised to the x power, which is 3, times 1 minus p, or the probability of failure, which is 0.83. I just took 1 minus 0.17, got 0.83, raised to the 7th power, or 10 minus 3 is 7. Here's our problem. We can do it using our calculator in 2 different ways, and I will show you both. And I chose a combination because we don't care how and what order the minorities are chosen, just that there are 3 of them. I'm going to multiply that to 0.17 raised to the 3rd power times 0.83 raised to the 7th power. And we get a probability of 0.15998, or my assumption would be, if you're rounding, 0.16. There's a probability of 0.16 that out of the top 10, exactly 3 of them will be minorities. Okay, so there's another way you can do this in your calculator. There's a binomial distribution function. Where you go is you go to Second and the VARS tab. And you see above that it says distrib. Just it kind of looks like an abbreviation for distribution. So go second, your VARs, and you've got choices here. We need to scroll down to the binomial PDF. The P means you're looking for exactly a number, which we are. And go ahead and hit enter. And this is what you put in. You put in your n first, 10, comma, your probability of success, comma, and your x. So let me write that down for you. You've got binom PDF, because you're looking for exactly. You want your n, your p, your x. And we should get the exact same answer. Drum roll, please. There we are. So however you want to do it, again, I don't ever care in my classes how you get to point B, as long as you get there. Okay, so let's look at the second part of this problem. what is the probability that there is at least one minority in the top 10? Here we are, guys, and I talked about this in a previous example. At least one should red flag you or throw a flag. There is a hard way to do this, and there's an easy way to do this. Or should I say a time-intensive way and a non-time-intensive way to complete this. So if we're looking at a probability of at least one minority, there's 18 of them, we've got to fill 10 slots. So probability of at least one would be the probability of 1 plus the probability of 2 plus the probability of 3, all the way to the probability that all 10 slots are filled with minorities. Now, if you wanted to do binomial distribution, either by hand or using your calculator, for every single one of these scenarios and add them together, you will get your answer. I'm not going to spend that much time on this problem. I know that a probability distribution in its entirety includes 0 minorities all the way to 10 minorities. I know that those probabilities have to equal 1 because you're looking for the top 10, and the only possibilities on the planet for that situation go from 0 minorities up to 10 minorities. And I know that all of that has to equal 1 or 100% of the probabilities or possibilities in this situation. So knowing that, I could calculate at least 1. I could do all of these calculations. Or why don't I just figure out the probability of none and take it out? What you're going to be left with is all of the rest of the probabilities added together. That is how I'm going to do it because I have other things that I need to do. So I'm going to do this in the calculator. I'm going to find the probability that 0 minorities make it. So we have 10. I'm going to choose 0. Probability of success, I don't want any. Probability of failure, I want them all. And failure and success, guys, are just the terms used. It doesn't necessarily mean failing or success. So keep that in mind as well. I'm going to go over to my trusty calculator, and I'm going to use this new method that I figured out. I'm going to go to second distribution. I'm going to go down to binomial PDF because I want exactly 0. We're going to put in total number, the probability, and how many I want. This is going to tell me the probability of no minorities in that top 10. Okay, so we have found that this amount is 0.155. So to find out at least 1 or 1 or more, we're just going to subtract the probability of none from the total, which is 1. 100% of the options have to be in the distribution. I know that the probability of 0 is 0.155, which means the probability that for the rest of them, the probability for the rest of the possibilities, which is 1 minority, 2 minority, 3, all the way up to 10, must be 0.845. It's in between 0 and 1. It makes sense to me, and so I am going to call it good.